Hello, everyone. So for this session, we will be discussing association rule learning. But before that, let's start with the story of the beers and diapers. This is a very popular story in the field of data science and data mining because it has so many applications. But the story goes like this. So a woman asked her husband to buy a diaper, and the husband is about 30 to 40 years old. He just came from the office, and it's a Friday night. It's about 5 to 7 p.m. This husband goes to a supermarket and buys a diaper. But along the way, he also bought beers. And this supermarket has conducted a study on this. And interestingly enough, this is not an isolated case. Many men are actually doing this. And because of this, they put the aisle of the diapers and beers beside each other. And this translated to an increase of 35% in sales. So this is one of the things that you could do with data science and data mining. You could perform those analysis, and then that could translate to business value. So that's an example of association rule learning. Okay, so overview. What is association rule learning really? It is often used in the context of supermarket data or market basket analysis, similar to the story that I have shared earlier. The goal is to determine the associations between groups of items, and it answers the following question: which items are often bought together? So some applications of that, well, again, the supermarket data could also be applied to text mining, the keywords and tags, which keywords are often used together or tags, and it can also be generalized to any dependency-oriented data types, such as sequential, spatial, or graph, because for graphs, they have to be connected, and for sequential, it has to be beside each other. So you could use association rule learning for these kinds of problems. Now, the techniques that we will be using will be doing frequent item set mining, primarily a priori, but the same logic applies to FP growth and ECLAT algorithms, but we won't be doing a deep dive on those algorithms. We'll also be using some statistical measures and similarity measurement. When we do association rule learning, we often use a market basket model. So what are the assumptions? So we have a large set of items, we have a large set of baskets or transactions, and each of those baskets contain a small subset of items. And with that, we want to discover the association rules. So people who bought X tend to buy Y. That's what we are trying to find. Okay. Okay, before we proceed, let's also discuss the difference of the online versus brick and mortar retailing. So in brick and mortar retailing, it's usually about physical stores, and physical stores have limited shelf space, unlike online. So we could basically recommend all the items, or we can have all the items in online because we don't have a physical space that we're using. So basically, in brick and mortar retailing, we have to target the very important items because we're limited. And that's usually what we're dealing with in the context of association rule learning. And I think this excerpt from the book explains that really well. So I'll be reading this. This is from the main resource that we're using in this course, the mining of massive data sets. So an online retailer would use similarity measures for items to find pairs of items that, while they might not be bought by many customers, had a significant fraction of their customers in common. An online retailer could then advertise one item of the pair to the few customers who had bought the other item of the pair. This methodology makes no sense for a bricks and mortar retailer because unless lots of people buy an item, it cannot be cost effective to advertise a sale on the item. Thus, the recommender system techniques, which we will be discussing in another session, those are not often useful for brick and mortar retailers. Conversely, the online retailer has little need for the analysis we discuss in this chapter, since it is designed to search for item sets that appear frequently. If the online retailer was limited to frequent item sets, they would miss all the opportunities that are present in the long tail to select advertisements for each customer individually. Okay, so we will now proceed to frequent item set mining, which is important before we can do the association rule learning. So what is frequent item set mining? Well, it is finding the set of items that appear together frequently in baskets. So we have the following terms that we use for this. We have item set, which is a set of items together, and support, the number or percentage of groups containing the item sets. So yeah, and we also have a support threshold. So we say that it is a frequent item set if it is greater than or equal to the support threshold. And we will be showing examples of that. So for example, you have the following data. You have the following items in your data set. You have an egg, beer, a juice, a milk, a diaper, and bread. It's this one. And you have the following transactions or baskets. So for the first one, you have bread and milk. The second one is a bread, a diaper, a beer, an egg, and so on and so forth. Those are transactions. And if we set the support threshold to 3, that means those item sets should occur at least 3 times in our data set. If that happens, then we say that's a frequent item set. So for example, as you can see here, we have bread and milk because it occurred 3 times in our data set. So here, 3, right? For the milk and the diaper, it occurred 3 times. So it's a frequent item set. And here's like another example. Say for example, we have milk, Coke, Pepsi, juice, beer, and you have the following transactions here, B1 to B8. Here will be your frequent item sets, the ones highlighted in blue. So for the milk item set, just that, you have a support of 5. For Coke, you have 5. For Pepsi, just 2. And since our threshold here is 3, it's not a frequent item set. For juice, it's 4. For beer, it's 6. So these are the singleton item sets. For the doubleton item sets, you have MC item set, which is just 2. So that's not enough. For MJ, it's 2 as well. Not enough. For MD item sets, we have 4, which is high enough. And CAJ is 3, CB 4, JB equals 2. So only MB, CJ, and CB are frequent item sets. Now, let's proceed to association rule learning. So what is association rule learning? This is the if-then rules about the contents of baskets. Basically, if a basket contains a certain set of items X, then it is likely to contain another particular item Y as well. So these are some of the measures that we will be using for association rule learning. You have confidence and interest. So what is confidence? This is the number of or percentage of groups containing the item sets, or basically just the probability that Y is also in a basket containing X. For interest, this is the amount by which the confidence deviates from the fraction of all baskets that contain Y. So these are the formulas for those. So the confidence for item set X implies Y is simply the union of X and Y over X. For the interest, it's the confidence minus the probability of Y. There are many rules that we can have in our data set, the thousands for a typical data set, but we only want to capture the significant or interesting ones. So let's try to compute the confidence first. So assuming the same data set, same transactions, we compute the confidence for the different item sets. So let's focus on this one first, the first row. So item sets MB. So you can see that there are 4 baskets containing them. So the denominator would be 4. Now let's compute MB implies C. So the transactions or baskets containing M, B, and C would be B1 and B6. So 2. So we have a numerator of 2, then denominator of 4. So that's 2 over 4 or 1/2 or 0.5. The same goes for the second row here. For MB, again, you have 4 transactions. So that's the denominator. But for MB implies P, you only have 1 basket. So that's 1. So it's 1/4. For MP, you only have 2. In the denominator, so 1/2. For CJ, you have 3 baskets. So that's the denominator. And for the numerator, you only have 2. For CJ, also 3 for the denominator, but the one with M is just 1. So now we have computed all the confidence values. Now let's say, for example, the confidence threshold that we'll be using is 0.5. Then that means the rules that we consider significant enough would be the following. The ones that are highlighted in blue. So it's MB implies C, MP implies B, and CJ implies D, because they have at least 0.5. So this one is 0.5 because it's 2 over 4. Then 1/2 is 0.5, and 2/3 is greater than 0.5. But not all high confidence rules are interesting. So we're now also incorporating interest here. So again, interest is the confidence minus the probability of Y. So the confidence for MB implies C is 2/4 or 1/2. But if we calculate the interest, we also have to deduct the probability of Y. So let's include it here. So you can see that C here has a count of 5 because it appears in 5 baskets or transactions. And the N is 8 because that's the full data set. So we have 1/2 minus 5 over 8, which is equivalent to negative 1/8. And that means the rule is not very interesting. Because the idea is item C appears in 5/8 of the baskets. So it happens a lot. So this confidence here doesn't really mean much if we look at the interest. So basically, you have lots of ways to identify if an item set is interesting or significant. You can filter the different rules using the minimum support, also the confidence and the interest. So yeah, that's it.